crystals like calcite and quartz. When light passes to such crystals, it splits into two rays instead of one. This phenomenon was first explained by the Dutch scientist Christian Huygen. According to him, double refraction is a phenomenon in which a single incident ray produces two refracted rays when two refracted rays inside a certain crystal. The two rays formed are ordinary ray and extraordinary. Ordinary ray and extraordinary ray. These two rays travel with different velocities and different refractive index. Because of this, two images are formed. This is Huygen's principle. According to Christian Huygen, every point on a wavefront acts as a source of secondary wavelets. Secondary wavelets means that it is a small source of waves, and the new wavefront is the envelope of these wavelets. Using this principle, Huygens explained the double refraction by assuming that anisotropic crystals like light travels with different velocities in different direction. In an anisotropic medium, the velocity of light is same in all direction. But in anisotropic crystals, velocity depends on direction. So, refractive index is different for the two rays. For an ordinary ray, the refractive index is P0 is equal to C by N0, and for an extraordinary ray, P is equal to C by NE. Since N0 is not equal to NE, the two rays are formed. This figure shows a positive crystal and a negative crystal. This is the O wavefront, and this is E wavefront, and this is the optic axis. In a uniaxial crystal, there is one special direction called the optic axis. This is the optic axis, and optic axis is the direction along which both rays travel with same velocity. Along optic axis, N0 is equal to NE. So there is no double refraction along optic axis. According to Huygens, when light enters a crystal, each point on the wavefront produces two wavelets. One wavelet is spherical and the one is ellipsoidal. So two wavefronts are formed, extraordinary and ordinary. This figure shows a crystal. This is positive crystal and this is the negative crystal. In positive crystal, NE is greater than N0. So velocity of extraordinary light is less than the ordinary ray. In this diagram, this circle represents the ordinary wavefront and the ellipse represents the extraordinary wavefront. The vertical line represents the optical axis. Example of positive crystal is quartz, and the example of negative crystal is calcite. In a negative crystal, NE is less than N0, so velocity of extraordinary ray is greater than that of ordinary ray. In this diagram, the circle represents the ordinary wavefront, the ellipse represents the extraordinary wavefront. According to Huygen, each point on the incident wavefront produces two secondary wavelets. ordinary ray, and one ellipsoidal gives extraordinary wavefront. The envelope of these wavelets forms two refracted rays. Thus, the light splits into two rays inside the crystal. This explains the double refraction. That is all about the Huygen's explanation of double refraction. The importance of this double refraction is it supports the wave theory of light and explains explains the double refraction clearly, and it is used in polarization and used in optical instruments.